Welcome to part 2 of the lesson on looking for patterns to write equations or formulas. In example 2, we're asked to determine the pattern and complete the table, graph the results, write a formula or equation to describe the relationship between the input and output variables. So the input variable is x and the output variable is y. Notice how we're given all the inputs. They start at -3 and go up to +3 and increase by 1 each time. And we're missing some of the outputs or the y values. So we'll begin by looking for a pattern to determine the missing outputs. Well, if we start at the output of 0, notice how going down, we have 0 and then 1 half and then 1. So notice how these outputs are increasing by 1/2 each time. So again, 0 plus 1/2 would be 1/2. 1/2 plus 1/2 would be 2/2 or 1. And then 1 or 2/2 plus 1 would be 1 1/2 or 3/2. Moving up the column, notice how the values are decreasing by 1/2 each time. So 0 minus 1/2 is -1/2. Minus 1/2 is -2/2, or -1. Minus 1/2 would be -3/2, or -1 1/2. Let's use -3/2. So we discovered enough of a pattern to find the ordered pairs. We have -3, -3/2, -2, -1, -1, -1/2, 0, 0, 1, 1/2, 2, 1, and 3, 3/2. Now that we have the ordered pairs, we'll go ahead and set up the horizontal and vertical axes and plot these points on the Cartesian plane. Notice how the x values go from -3 to +3, and the y values go from -3/2 to +3/2. So let's first sketch the horizontal axis, and then the vertical axis. And for the horizontal axis, let's go from +4 to -4. So let's go ahead and scale this by ones. So we'll divide the interval from 0 to 4 into 4 equal pieces, here, here, and here, using tick marks. So we have 1, 2, 3, 4. To the left, we'd have -1, -2, -3, and -4. Notice all the input values will appear on the horizontal axis. And now for the vertical axis, instead of going from -3/2 to +3/2, or -1 1/2 to +1 1/2, let's go up to +2 and down to -2. And let's scale this by 1/2. So we'll cut or partition the interval from 0 to 2 into 4 equal pieces. Let's say here, here, and here. So now we'll count by 1/2 up from 0. So we'd have 1/2, 2/2, or 1, and then 3/2 or 1 1/2. Let's write this as 3/2. And then finally 2. In the negative direction, we would have -1/2, -1, -3/2, and -2. Notice all the outputs appear on the vertical axis. Now we'll go ahead and plot the points using the ordered pairs. So the first ordered pair is -3, -3/2. So because the input is -3, we go to -3 on the horizontal axis. Because the output is -3/2, we go down to -3/2, which should be here. Notice how we have an input of -3 and output of -3/2. Next we have the ordered pair -2, -1. So the input is -2 and the output is -1. Next we have -1, -1/2. The input is -1, the output is -1/2. Next we have the ordered pair 0, 0, which is at the origin. Then we have 1, 1/2. So the input is 1, so we go to 1 on the horizontal axis. The output is +1/2, so we go up to 1/2 here, where the output is 1/2. Next we have 2, 1, input of 2, output of 1. And finally we have 3, 3/2. So the input is 3 and the output is 3/2. So now we have a graph of all the ordered pairs. We need to write a formula to describe the relationship between the input and output values, which means you want a formula or equation that when x equals -3, y equals -3/2, when x equals -2, y equals -1, when x equals -1, y equals -1/2, and so on. To help us write our formula or equation, let's focus on these 3 rows here. we want a formula or equation that when x equals 1, y equals 1 half, when x equals 2, y equals 1, when x equals 3, y equals 3 halves. Notice how the output value is always half of the input value, which means our symbolic rule or formula is going to be y the output equals x the input divided by 2. If we wanted to, we could also write it as y equals 1 half times x. But let's use this symbolic rule here, and let's test the other values in the table. Notice when x is negative 3, we'd have y equals negative 3 divided by 2, or negative 3 halves, which is what we have. When x equals 2, we'd have y equals negative 2 divided by 2, which is negative 1. Let's go ahead and test this ordered pair here. Notice when x is 0, y is equal to 0 divided by 2, which is 0. So this symbolic rule is correct, but let's also check this on the graphing calculator. So we'll press y equals, clear out any old equations or formulas, we'll enter x divided by 2. Enter, and now we're going to press second graph to compare this table with the table that we have. Notice how the tables do match. Negative 1.5 does equal negative 3 halves, negative 0.5 is negative 1 half, and so on. So this verifies that our symbolic rule or formula for this table is correct. Now let's also look at this graphically. Before we do this though, let's adjust the window on the calculator to be the same window we have here on the Cartesian plane. So we'll press window, we'll change the x min and x max to negative 4 to positive 4, so we'll enter negative 4, enter, 4, enter. Scaled by ones, that's correct. Go down to y min and y max. The y min on our vertical axis is negative 2, and the max is positive 2. So negative 2, enter, positive 2, enter. Ours is scaled by halves, so let's enter 1 half here, enter. And now let's go ahead and press graph. Notice here we actually have a line, not just a set of points, and that's because once we write the symbolic rule or formula, this is telling us that the output y is equal to the input x divided by 2 for any input x, not just these inputs. So now that we have the symbolic rule, let's go ahead and sketch the line passing through the points we already plotted. And again, we're sketching the line now because we wrote the symbolic rule, and once we have the symbolic rule or formula, every point on this line has meaning the coordinates of every point on this line, or the ordered pair for every point, would satisfy our equation or formula y equals x divided by 2. And because the inputs can be any real number along the horizontal axis, we now have a continuous graph rather than when we had just a set of points, which would be a discrete graph.